Everyone, this is Ann Walhout, Association Coordinator of ISSA. Thank you for joining us today for the ISSA Leadership Development Team webinar, Introduction to Crack Treatments. We do have you all on mute for today's webinar, and we'll be using the question function on the side of your screen for any questions that you may have during the presentation. All questions will be answered at the end. This webinar is being recorded and will be provided to all registered attendees in the coming days. I would now like to pass it over to Joe Brandenburg, one of the chairs for the Leadership Development Team, to introduce today's speaker. Joe?
Thanks, Ann. James Clark is a territory manager for Craftco and covers the states of Utah, Colorado, Idaho, and Wyoming. He has over 10 years of experience in the construction industry and has spent the last 3 years with Craftco specializing in crack sealants, mastic products, and crack sealant equipment. James lives in Syracuse, Utah with his wife, Kayla, and 2 kids, Hunter and Davis. Please welcome James.
Thank you for that introduction. I'm excited to do this presentation today for ISSA. I'm glad they asked because this is my favorite topic to go over, and I hope you learned something. If you have any questions, definitely write them down in the chat section, and then we can address them at the end of the presentation. So let's go ahead and get started. Introduction to crack treatments. This presentation will explain crack treatments, crack filling, crack sealing, why crack treatments are beneficial and how they are used as a pre-treatment with other preservation methods. After pavements are constructed and are in use, they will eventually develop cracking due to a range of factors such as pavement design, construction practices, climate, and traffic loadings. Crack treatments are a cost-effective pavement preservation method that extends the life of your pavements. There will be a brief review quiz at the end of this presentation just to ensure understanding of the content that was given. Crack treatments are methods in which cracks are directly treated through sealing or filling operations. These 2 methods are called crack sealing and crack filling. Crack treatments are cost-effective pavement preservation methods that extend pavement life, protect your investments, maintain pavement structures, limits deterioration, and prevents potholes. We all don't like potholes, right? There are 2 important differences between crack sealing from crack filling. The first difference is the objective of the treatment. Crack sealing is designed to prevent the intrusion of water and incompressible materials into the crack in order to stop further deterioration and pothole formation. So crack sealing requires a more refined material and installation. Crack filling is designed to reduce intrusion of water into low-moving cracks. The second difference is the type of materials used. Crack sealing uses specialized treatment materials that are flexible and elastic, whereas crack filling uses ordinary materials suitable to fill the void and reinforce the weak and adjacent pavement. In addition to the 2 main differences between crack sealing and crack filling, there are other distinctions. For example, crack sealing uses highly elastic or flexible materials that is designed to endure vertical and horizontal movements. On the contrary, crack filler is rigid material that can't handle movement. For crack filler, once expansion and contraction or movement occurs, the effectiveness is lost, so water and incompressible materials enter into the crack. Repeating crack filling treatments may be necessary every year if that's the solution you're going for. Crack sealing involves thorough crack preparation, which may or may not include routing to clean and develop a reservoir for placement of the sealant. Crack sealing includes placement of sealant in a particular configuration chosen to provide the longest lasting seal. Crack filling requires very little preparation and applying ordinary material into the crack. Crack filler is placed in the crack and typically requires dusting with sand to prevent tracking of materials. Crack filling creates a temporary fill that can last from a few months to 1 year. Crack sealing and crack filling use different materials. Crack sealing uses specialized materials like asphalt rubber, rubberized asphalt, and low modulus rubberized asphalt products. These are engineered to enhance properties such as flexibility, elongation, and low and high temperature extremes, which these seal the crack and prevent infiltration of moisture and debris. Crack sealants add an average of 5 years to the life of the pavement, and studies indicate that sealing on new asphalt surfaces will last 7 to 10 years. Crack filling uses ordinary materials like asphalt cement, cutbacks, asphalt emulsions, sand asphalt mixes. Fillers possess little flexibility and are temperature susceptible. Therefore, they are limited to use as fillers in some low moving cracks to simply fill some of the void of the crack and reduce infiltration. Because fill materials harden quickly, most filling operations must be repeated to be an effective crack solution. Expected life of crack fillers range from a few months up to 1 year. So here's a couple photos of both type of operations. On the left, we have the crack sealing operation, which a lot of us are probably susceptible to. You have specialized equipment that's heating up the material to its application temperature. Application temperature is important because you get proper adhesion of the product. It's being installed at the end of the wand there to fill the crack, seal the crack, and prevent water from infiltrating and incompressibles to infiltrate that area. This is the longer solution. Crack sealing is where you can get, if the right material is chosen, an easy 5 years life out of the sealant and extends your pavement life. On the right there, you see a crack filling operation. Less specialized equipment. You see a guy shoveling some material out of the back of the end dump. He's spreading it around, filling the voids. This is not a flexible solution, so this is the type of solution that you see lasts only a couple months up to a year. Crack treatments are the most cost-effective pavement preservation method. This method extends pavement life, protects your investments, maintains pavement structures, limits deterioration, and prevents those potholes, those pesky potholes. See the picture on the left, water is penetrating that crack and is starting its damage underneath, washing out your subbase. This is where interconnected cracking comes from. One crack leads to several cracks. Crack sealing prevents water from penetrating that area. On the left, you see a picture of incompressibles entering the area. As the pavement expands, that's where you start to see that raveling, that bump up of the asphalt itself. A question that arises when planning crack treatment projects is that what time in the life of the pavement should crack treatments be performed? From purely functioning view, to gain the maximum and longest lasting benefit, the most effective time to crack seal is as soon as the crack forms, right? But from a practical standpoint, however, there needs to be a quantity of cracks present to justify the cost of the project. Timing is generally decided considering pavement condition, type and amount of cracking, crack width, and local conditions. 1% crack density in the pavement is a general guideline to begin crack treatments in order to preserve your pavements. Most highway agencies have established policies that specify the type of maintenance to be performed on the cracked pavements and when to perform it. These policies are often based on the assessment of the overall pavement condition or specific crack characteristics. And this is a graph, I like to say a universal graph that we see out in the industry. Your typical pavement deterioration is that red line, and you know, when we crack seal near the good to fair condition, we're spending a small investment towards our crack seal, and it's significantly extending the life of your pavement. If you let it go too far, you're spending, you know, more on rehabilitation and reconstruction. So it's important to get on the cracks as early and often to extend the life of your pavement. So we talked about crack treatments as a standalone treatment. However, keep in mind that crack treatments are also commonly used as a pre-treatment in conjunction with other surface treatments like fog seals, slurry seals, HMA overlays, chip seals, or microsurfacing. Cracks will reflect through the surface treatments, and untreated cracks will continue to deteriorate. Treating the cracks prior to any surface treatment is vital to assuring that the desired performance of the surface treatment is being attained. Sealing prior to the surface treatment enhances the treatment and further extends the pavement life. You may hear from others that surface treatments provide crack sealing and crack filling properties. Keep in mind that surface seals will seal very narrow hairline cracks up to 1/16 of an inch wide in width. For larger cracks, and especially moving cracks, it is very important to pre-treat these cracks in crack sealing, then follow with the desired surface seal. So crack seal before the surface seal. The surface seals will do a good job at filling up those hairline cracks, but it is a crack filler at that point. Larger ones need to be crack sealed to ensure extension of your pavement life. Next couple of slides are going to review the value that crack sealing provides to those surface treatments. NCAT completed a comprehensive 3-year study evaluating 25 treatments. There were a variety of results, but relevant to this presentation, we're going to be talking about how crack sealing reduced developmental and interconnected cracking and reduced subgrade moisture levels. We'll also talk about how crack sealing as a pre-treatment improved other surface treatments as well. On this experiment, there was 25 sections on this experiment, 2 of which were controlled sections. The purpose of the study was to quantify life-extending benefits of the study treatments. This slide displays the control values over the 2-year period that this experiment went on for, 2 years. The control is defined as normal cracking, as if no treatment was applied. So we will compare the changes over the next couple of slides, and we're going to review the results of the changes versus the control. So this is your control section. The red line on the next coming up slides is your control at 100% cracking. This slide reports the crack sealing section versus control, so no crack sealing. At 1 year, there was 100% less cracking. At 2 years, there was 75% cracking, less cracking. So right off the get-go, as a standalone treatment, crack seal reduced after 2 years, you're cracking by 75%. And here is a picture of the road, Atlee Road, that the experiment was done on. This white line identifies, before the white line is cracking without crack seal, and the white line after is crack sealing, is the crack sealing section. So we're going to talk about chip seals first. This is a slide that reports the amount of cracking after a chip seal that had no crack sealing pre-treatment. At year 1, there was 100% less cracking. At year 2, there was 25% more cracking. So those cracks reflected through the chip seal you know, after just 2 years, we're seeing 25% more cracking. Using crack seal as a pre-treatment, after 1 year, we had 100% less cracking. At year 2, we had 100% less cracking while having crack seal as a pre-treatment underneath a chip seal. So by crack sealing as a pre-treatment prior to the chip seal, you went from 25% more cracking with the chip seal alone to 100% less cracking with a chip seal over a crack seal. This is a small investment that's yielding a large return. Here's a picture of those two control sections. See if we can zoom in on that. That white line there separates the two sections. So the first section that you're coming up to is the chip seal with no crack seal treatment. And then the section after the line shows a section with crack seal as a pre-treatment, and you're not seeing any cracking reflecting through. So we're eliminating the chance of water penetrating that area. Double layer chip seal with no crack seal pre-treatment. There was 100% less cracking. Year 2, 75% less cracking. So a single chip seal with crack seal performed better than a double layer chip seal. Same thing with the triple layer chip seal. A single layer chip seal with crack sealing performed better than this graph here, which is a triple layer chip seal. Even though it's yielding great results with the triple layer chip seal, but your costs are significantly increased if that's the route we're going. Microsurface. This slide reports the amount of cracking after a microsurfacing that had no crack seal treatment. 50% after 1 year, 15% after the 2nd year. Let's compare that to crack seal as a pre-treatment. 90% less cracking after year 1, 60% less cracking after year 2. So by crack sealing as a pre-treatment prior to microsurfacing, you went from 15% less cracking with microsurfacing alone to 60% less cracking using crack seal pre-treatment. Again, the small investment is yielding a large return. Here's a couple pictures of that control section for microsurface. Here's a good one here, the angle. We're not seeing a lot of cracks reflecting through with the crack seal as a pre-treatment, as the section before, they've all reflected through. Summary, crack sealing alone reduced cracking 75% compared to no treatment, reduced cracking 100% with chip seal, and reduced microsurfacing 45% with crack seal as a pre-treatment after the 2-year period. And there was an update recently from the NCAT study that went up to 2018. So we got 5.5 years information on this. It's presented in a different format, but we're going to go over those results real quick to see what 5.5 years can do for you. Data on this page reports your control section without cracking, or sorry, control section without any pre-treatments or surface treatments. It's showing your poor, fair, good condition. The line on the left is your percent cracking. On the bottom, you've got your age in years. So we're going to compare this to, this is our slide we're going to compare to our surface and pre-treatments. Crack seal only. We treated cracks in the area listed as poor by standards used here showed significant improvement. So your poor pavement has significant improvement after 5.5 years with crack seal as a pre-treatment. Single layer chip seal. Just the chip seal alone to the uncontrolled section, you're seeing significant improvement, but with crack seal as a pre-treatment, Yeah, you're seeing improvement on your good, fair, and bad on the chip seal. But with crack seal as a pre-treatment, we're seeing an extensive boost in your pavement condition. Poor areas here shown, greater improvement with crack sealing. So you're seeing you're less than 10% crack in these areas after 5.5 years, which is a huge boost. Same thing with fair and good condition. We're seeing significant boost where that pre-treatment is extending the life of your chip seal. Microsurface. Microsurface without crack seal as a pre-treatment is showing improvement over 5.5 years. But we'll compare it with crack seal. Huge boost in numbers. Crack seal is extending the life of your microsurface as well. Crack sealing before microsurfacing on the poor areas for this pavement shows far bigger improvements. Good pavements with crack sealing before also does show very real improvements, which is greater than the improvement with just the microsurfacing. Here's a summary of improvements. This breaks it down so it's easier to read all those colorful graphs we just had. Chip seal plus crack seal shows you the crack reduction, percent crack reduction. We're seeing 72% crack reduction on poor, 50 on fair, 87 on good. So you're seeing a big boost with crack seal as a pre-treatment. On the microsurfacing, it's grown your pore condition with the reduction of 41% crack reduction in that area. Is there any questions on this presentation so far? Let's check the chat.
We don't have any questions so far, but that speaks to what a great job you did. I mean, your slides are very well done, but I have a couple of questions, or one especially. So with all of your data that supports how much improvement there is when crack sealants are used or crack treatments are used as a pre-treatment, how do you feel that specifications are supporting this? Is it spec'd in a lot?
Well, it all depends. A lot of specifications or crack seal programs tend to get on top of roads, 6 to 7 years life cycle, where we should probably be thinking about getting on pavements sooner with crack seal, because especially our cold joint paving areas, I mean, that area alone is opening up within 1 to 2 years. The more life we have go by while those cracks are open and water is penetrating, the more damage we're going to be doing with our pavements. Specification wise, I think it's very important if we have specifications or if we have a program set on what type of material we're using. I would think it's very important for us cities, counties, just to evaluate what type or what life we're getting out of the sealant that's being used on our roads. Just as important as applying the material is, what type of material we're using. Depending on climates, Las Vegas and the mountains of Utah are going to be using 2 different types of material. So ensuring that your pavement is performing the way you want it to, and if not, we should probably adjust our specifications and find what product works best for us.
Okay. An attendee is asking, James, can you be more specific on how you define percent reduction of cracking?
Yes. We have a formula where it's trying to find the the percentage of cracking on your roads. Off the top of my head, I can't give you that formula off the top of my head, but I can definitely share that with this group so we have a way to find the percent cracking of our roads. Was that the answer to the question, or I guess addressing the question?
Yes. And I think that the fact that there is some sort of calculation that is done probably answers the question, partially answers the question. But yes, they were just inquiring about how the percent reduction of cracking is defined?
Reduction of cracking. Percent reduction of cracking. Yeah, definitely. Let me get that information out to this group so we can
Okay.
share that information for sure. Let me make a note here. So
Okay.
on the slides on how they figured out percentage reduction of cracking, is comparing the two sections, right? The control section, they know how much cracking they're having on the control section when they're getting down and they're measuring the width and the length of the crack. And then they're comparing that to the section with the pretreatment to see what percentage decrease in cracking they're having, if that makes sense.
That's perfect.
Yeah.
And another question, early in your presentation on one of the first few slides, you described you had asphalt rubber and rubberized asphalt. What is the difference between the two?
We're just talking about the type of crack sealant you're using. We're talking about, let me go back on that slide real quick.
Yes.
And we're talking about the difference between crack sealing and crack filling on that section. All it is the type of material you're using as a crack sealant, right? So there's different types. There's a low modulus, there's a asphaltic rubber, which all speaks to the type of performance this material is going to be giving you. This ASTM 5078 is a different type of ASTM than the D6690, and it's more about performance, what it's used for when it comes to climate, and the type of cracks you're sealing with it. Some areas thrive with this 5078, where some areas need a more flexible, resilient material like a D6690 specification. So it all depends on what material works well in your area.
Perfect. Okay. Well, I think that those are all of the questions that were submitted. So I think you did a tremendous job. Thank you so much.
Thanks. And then we do have some questions at the back, so we can, check to make sure my voice didn't put anyone to sleep, which would be great. Yeah, let's check. Do we have those polls set up where we can ask the audience? So which of the following types of treatments materials are used for crack sealing? That's A, warm mix asphalt, B, asphaltic emulsions, C, asphalt cutbacks, or D, modified asphalt rubber. And this is for crack sealing. Okay, I believe the poll is closed. Most of us got it correct. 88% picked modified asphaltic rubber, and that is the correct answer. Crack sealing is a more extensive engineered material designed to seal the area and perform on high moving cracks, vertical or horizontal movement. Crack fillers are the more temporary products, just using warm mix asphalt or emulsions or cutbacks. These products won't give you long life in your preservation treatment, where we're only seeing a few months to a year, where modified rubber or asphalt rubber is designed to last 5 years for you. So let's go on to question 2. Hey, Jamie, I couldn't switch over to the next question.
Can you see people are finishing this poll?
Oh, okay, sorry.
No, you're good. The poll is in progress.
So this question was, which of the following is not a characteristic of crack filling materials?
Okay, the poll is closed.
Poll is closed. So let's show the screen right here. Yeah, which is not a characteristic of crack filling. The answer, which most of us got 80%, is to seal the high moving cracks, and that is correct. Again, crack filling is made up of rigid, semi-rigid materials. It's considered a temporary fix. It fills some of the crack void to reduce the water intrusion of water, but it's not a extended life product. It'll keep water out, but it's not going to seal for high moving cracks. So most of us got that. Okay, and we'll go on to the next question. This question is, crack blank is the placement of specialized treatment materials to blank the intrusion of water and incompressible materials into the crack. Okay, a couple more seconds. Okay, now we're closed. Let's go to the next slide. Okay, yep, the 76% of us said sealing and prevent, C, which is the correct answer. Specialized treatment of materials, so it's a crack sealing product because it's specialized to work with your climate, your high moving cracks, and seal and prevent water from penetrating. I know it says reduce, and it does reduce water from penetrating, but it's specialized to prevent water from penetrating the area at all. Where I don't want to say that's a trick question on the sealing and reduce, but it's to prevent the water from penetrating. Okay, we got one more question. No, we got, yeah, I think this is the last question. Question is, crack blank is the placement of ordinary treatment materials to blank the intrusion of water and reinforce the adjacent pavement. Okay, just close the poll. Most of us got it correct at crack filling is the placement of ordinary treatment materials to reduce the intrusion of water and reinforce the adjacent pavement. So the answer was A on that. 79% of us got that correct. Crack filling reduces the amount of water intrusion because it's a temporary product where we're only seeing a few months to a year. So once that opens up, we're letting water penetrate that area. And crack filling is not designed to seal the area and move with the working crack. So it's not going to prevent the water from penetrating, but it will reduce the water from penetrating for a temporary time. For the most part in the industry, we're seeing crack sealing way more than crack filling because we're spending the time and labor to address this area. We don't want to keep coming back and trying to fill the area to prevent water from penetrating. Crack sealing is normally what we see out in the industry. It's what we promote because you're going to get longer life out of your pavement. So you might not see crack filling as much, but just know crack sealing is more of a extended lifetime product as to where crack filling is a temporary product.
I think there's one final poll.
Okay. Okay, poll is open. Which of the following is not a characteristic of crack sealing materials? Not a characteristic of crack sealing materials. Okay, we're closed. I don't want to say this was a trick question because the answer was D on the bottom. Crack sealing is only designed to perform up to 1.5 inches in width of the crack width. Anything more than that, we should be using a hot applied mastic product, which we didn't cover in this presentation, but the process of elimination, right? Crack sealing does seal high moving cracks and low moving cracks. It requires crack preparation to ensure long service life of the material. It endures horizontal and vertical movement. Crack seal is designed to penetrate the crack and move with all of these movements we see with climates, freeze thaw, expansion, contraction of the cracks, horizontal, vertical. I mean, it's designed to seal the crack and not allow water to penetrate into the area. I'm glad a lot of us answered D because if you know what mastic is, great. Mastic is a great product to seal larger cracks. I wish I had more information on this for you today, but we'll definitely have to do a presentation soon for ISSA on this type of repair as well. But that's all I have for you. We do have some time, so if you do have questions, you can put them in the chat and we can address them and kind of go from there.
We don't have any more questions that have been submitted, but again, I think you did a tremendous job. You covered this topic on crack treatments very nicely. So thank you again for being the presenter for this webinar. And for everybody that attended, we had great attendance for those that registered. So thank you again, and look out for future communication for additional webinars through ISSA's leadership development team. Joe, do you have any other comments to add before we close out?
No, I don't. But thank you so much for your time, James. We definitely appreciate it. And thank you to all the attendees as well.
No, I appreciate the opportunity. Thanks, guys.